Hey everyone, so today we're going to be doing another question from Elements of the Programming Interviews in Python. This one is called Intersect Sorted Arrays. So given two sorted arrays A and B, possibly with duplicates, we want to return the intersection of both arrays without duplicates. So an intersection is a set that any element in this set is both in the first set and in the other set. So if we have A and B, then every element in the intersection is also going to be in A and in B. So for example, if we're given 1, 2, 2, 3, 5, and 2, 3, 7, we see that 1 is in the first array, but it's not in the second array, which means it's not going to be in our intersection. However, 2 appears in A and B. In fact, it appears twice in A. However, we're not including duplicates, so we're going to put in just 1, 2, and we're going to put in 1, 3. So we could do this with set manipulation, but a more elegant solution without extra space would involve traversing arrays A and B, keeping track of which elements are the same in it, and then we can either return that in a separate array, or we can actually store the result in one of the initial arrays, and then return a slice of that. So this is the method that we're going to go about, and if we're going to visualize this, we're going to have a pointer to the first element in A, we're going to have a pointer to the first element in B, and we're just going to iterate until they match. So here we'll have 2 and 2, we're going to add 2 to our set, and then we're going to move on. We're going to see 3 is in both arrays, we're going to add that to our intersection, and then neither 5 nor 7 are in both arrays, so then we're just going to finish. So we'll call our pointer in A little a. We'll say A equals 0. We'll call the pointer in B little b. We're going to call that 0 as well. We're going to have a pointer, and then we're also going to have a pointer to the index that we're writing to. So we're going to call that W for write. So we're going to set that to 0 as well, and we're going to store our result in the array A. So let's say while A is less than length of A and B is less than length of B, because we want to iterate over both elements, we'll say if A of A is less than B of B, then that means our A pointer is slightly behind B. So if it's slightly behind, we're going to have to increment it. We're going to say A plus equals 1. Otherwise, we're going to say elif B of B is less than A of A, so it's going to be the inverse of the previous situation. So now B is behind, we're going to say B plus equals 1 because B needs to catch up. Otherwise we know that the value at A and A is equal to the value of B and B, so all we need to check really is if we've already written a write to our index, that means we don't have a duplicate error. So we say elif P is greater than 0, because if it's, or W is greater than 0, because if it's greater than 0, then we've already written an element. And if A of A equals A of W minus 1. So we're going to check what's the previous element that we've written. And if that element is duplicate, we're going to say, we're going to skip both. So we're going to say A is going to equal A plus 1, and B is going to equal B plus 1. So we're going to say A equals A plus 1, B is going to equal B plus 1. Otherwise, this means we don't have a duplicate, and A of A matches B of B. So if they do match, we're going to say A of W, our right index, equals A of A, and then we're going to have to increment every single index. So we're going to say A, B, W equals A plus 1, B plus 1, W plus 1. And then at the end, when we leave this array, that means either we've exhausted all the elements in A, or we've exhausted all the elements in B, possibly both. In which case, there's definitely no more elements that could possibly intersect the arrays, in which case we simply return a slice up to our right index, which hasn't been written to yet. So it's going to be the length of our new string. Let's try this out in our EPI judge tester. Looks like we have a syntax error. on the else if. Let's try it out now. So here we've passed all our test cases in pretty fast time, and the runtime here is of course O of n plus m, where n is the length of A and m is the length of B. They might have different lengths, but it's going to be a sum of them, or whatever the max of it is. And this is simply because we will have to iterate over possibly both of the arrays to do this. And one thing to note as well is that whichever array is smaller will always be the limiting factor in our set. So if A is really small, then we only have to iterate over all of it. So actually the time complexity would actually be the minimum of the lengths. So if length of A is, if A only has one element, that means there's only one candidate for the intersection. Even if B has a million other elements, it doesn't matter because there's only one possible value that could intersect. Similarly, if A is very long and B is, only say 5 elements, that means we can't have more than 5 elements in our intersection because our intersection is going to contain elements from both arrays. And using this method, we can quickly make sure that we do check every single value, but we don't do any redundant passes over the array. So we've looked at every element exactly once, and we actually store the result in one of our founding arrays, giving our space complexity to be O of 1. Hopefully you enjoyed this video. If you did, please like, comment, and subscribe. And if you're looking for some personalized interview help, head on over to our website or fill out the Google Docs for personalized interview help, for example, mock interviews, mentorship, or resume reviews, or any other interview services you might need. Thank you for watching this video, and have a great day.